Today we start a new topic called relational modeling. Now, the relational modeling is in three parts. The lecture is in three parts. All right. Today we are going to focus mainly on what an RDBMS is, what is an entity relationship diagram, how to identify and apply keys and constraints in a database, how to apply normalization up to the 3NF, how to recognize the benefit of relational modeling. That's what we want to do today. To start with, what is relational modeling? When you are referring to relational modeling, normally you are referring to a case where you want to break down data into smaller related tables. Generally, data may come in a big table, but you want to break down these data into smaller table. For what purpose? There are different reasons why you want to do that. You may want to break data into different parts to avoid repetition, to reduce errors, to reduce errors because sometimes in the big data you might have errors that will occur if you are modifying certain aspects of the data. You might have repetition in the data, and you want to make it easier to manage and query large databases. That's why basically you want to break down data into smaller related tables. Related tables, all right? That's where we come to the concept of relational modeling. Of course, the tables have to be related for us to break them down. Let me just give you a small example so that you understand the idea of what I tried to explain. Let's talk about a small data, all right, where you have a customer name, you have the address, that is the district of that customer, you have the product purchase, the product category, whether it is appliance, you have the purchase date, you have the payment method. Of course, let's suppose it is Coates Mahmoud, for example, who records all these information. Now, this is a large flat table, as you can see. Generally, data are not like that. This is just for illustration purposes. You might have more columns in that data. For example, instead of having district, you might have more specific addresses. You may have the phone number of the individuals, but just trying to keep it simple right now. You can also have an email address. You might have so many other details, but just to make things simple, let's stick to that example here. All right. Uh, Now you can have all these different information. For example, here you will see that there is a person called Brinda Mahesh who lives in the district of Mocha, and that person has purchased a refrigerator, which is an appliance, on whatever date that you see here, using her credit card. Okay, and then you have Elijah Peter, etc., etc. And then you will see that Brinda Mahesh again is buying a television now, which is an appliance on whatever date and cash now. So you see that there are records, and you will see that Brinda Mahesh is purchasing, appears twice in that uh, data here, where you have Brinda Mahesh bought once a refrigerator, once a television. So what do we want to do is that, let's suppose tomorrow, for certain reason, Brinda Mahesh does not live in Mocha anymore, but lives at QPIP, for example. If Brinda Mahesh lives at QPIP, you would want to change that and put it as QPIP. And you would want also to change that and put it as QPIP. But you see, the issue with that kind of manipulation is that when you are dealing with big data, remember that our course is about data analytics and we are working with big data generally. When you are working with big data, you might have maybe hundreds of thousands of records or maybe millions of records, let's suppose. You might have several columns, maybe 20 columns, maybe 30 columns, maybe hundreds of columns, I don't know. And doing such type of manipulation may be quite risky. Why? Because let's suppose to change here qubit and for certain reason you forget to change here. That's not going to be a very good thing. You will come up with data that is not accurate in the end. So we want to ensure that if we are doing a modification somewhere, this will change everywhere, for example. So what do we want to do is that we want to break down this big, let's call it big, it's not really a big table, but let's call it a big table. We want to break that into smaller tables where these smaller tables will have relationships among each other. Let's start by, first of all, we have here details pertaining to customer. Then you have details about the product that they purchased. For example, their product category and the product they purchased itself. And then you have purchasing details, that is, details related to the date of purchase and the payment methods. I can call it in three tables. I can break this down in three tables basically. To start with, let's talk about the customer table first of all. Now, when you look at the customer table, there are basically, if you look at the number of customers that we have Brinda Mahesh and Woka district, you will see that there are only six customers. All right, there are only six customers. Even though you have seven records here, you have only six customers. So I can write down the customer names and their district or whatever details I have, their email or whatever, and then I can also have to an ID that represent each of these customers. Generally, the ID that I will put here is supposed to be a unique identifier of each row within that table. All right. So you have COO1, which is supposed to define only one person, and we expect that there are no duplicate records for that customer table. So you will see how efficient it becomes. You see, you're not repeating a data here. This is repeated here, this is repeated here, but in this particular context, you don't repeat the Brinda Mahesh twice because we are dealing only with customer table. So if a customer table, it's only one Brinda Mahesh who lives at Mocha. Then now you can go for the product details like product purchased and the category. Again, you can create an ID for these different product name and product category. If we go back here, you will see that there is refrigerator appliance has one product, television appliance has a second, third laptop, fourth this one, fifth this one, sixth this one. But this one is not a seventh type of product purchase and category because it's already there for Elijah Peter. So Elijah Peter purchased a television appliance and Brinda Mahesh also purchased the same thing. So if you look at the number of products purchased, again, you will see that there are again six and I can define them for a different identifier as you see here. So you can define these, you have six here because there is a repetition in the flat table. And then, of course, when we are done with that, we can get the purchasing details. The purchasing details, obviously, it will include the purchasing date, the payment method, but it will also include the customer who purchased it, and not only the customer who purchased it, but also the product purchased. So that last table will be a summary of all these different information. Like here, you have a purchase date, you have the payment methods as you see, but then you have an ID with regards to the purchasing details. As I said here, let's call it TO1 and up to TO7, just like in the flat table here. But the only difference is that now the customer ID will be repeated twice, CO1 and CO1. But look at that. You don't put now the customer name and the district. You see that there is only the customer ID And that customer ID of CO1 automatically is linked to the customer table here, where CO1 represents Brinda Mahesh from Mocha. So here you see that this time you just need to put CO1 here, and you don't need to do any you don't need to include rather the mocha and all these details. Then you have the product ID that is purchased. You will see that Brinda Mahesh purchased a refrigerator and an appliance. So that is supposed to be linked to the product table with refrigerator and appliance. As you will see, it is PO1. So he purchased product ID PO1 with all the details relevant to that product ID. And of course, the second person, Elijah Peter, bought a television appliance, and you will know that Mahesh bought television appliance. So we know that the second person and the second record and the eighth record would the second one, as you see here, is PO2, and the last one would be PO2 again. So that's how you can build a relational database by breaking down that big table into smaller tables. What's the advantage of all this? As I mentioned to you, let's suppose Brinda Mahesh does not stay in Mocha anymore. The only thing that you will need to do is just to change that Mocha only once. And given that the purchase is linked to customer ID, and this customer ID COO1 fetches information from the customer table COO1 who is Brina Mahesh Muka. What happens is that if you have changed it only once, automatically you don't need to worry about this customer ID, that person represent, and this customer will represent, because they are the same person, and you don't need to do any modification like if it was in the previous table. If you have changed Mocha to QPIP, you would have had to correct that to QPIP, and you would have had to correct that to QPIP again twice. But let's suppose you have so many records like that, it will become very tricky and difficult to do that. That's why, to avoid doing these kinds of things and making errors, it's just that you need to correct it only once in your customer table. The rest is being taken care by the linkage that exists between the purchase table and the customer table, obviously. So logically, he knows that the purchase table, when it is COO1, it includes Brinda Mahesh, obviously. And the same thing applies for PO2. So you've got an idea of what we just did here. Instead of having a single flat table, we have multiple tables which are linked to each other. That's what we refer to as the concept of relational database. So we are talking about relational modeling, and that's what we are doing here. We want to model those kinds of relationship that exist among different tables in a data. All these, of course, as I explained to you, for many reasons, is that you want to do that to avoid repetition, like to reduce errors, to make it easier to manage and query the large databases. All these are the different reasons why you might want to do that. Now that you understand the concept of a relational database, we can get into what we call a relational database management system to understand better what it is. All right, let me get into that. So we want to now get into what an RDBMS is. Understanding relational database. I've created a small interactive chart to make things easier for you. I will avoid repeating what I've already said, but let me just get into that quickly, just to give you an idea of what it is and what are the concepts that you need to grasp when we are talking about a relational database. So I've already explained to you briefly what a relational database is, and I gave you another example here so that you can have a look at. So how does a relational database, what is a relational database management system? First of all, when you talk about a relational database management system, it is a software that receives and processes the SQL query that you have. It's basically like the brain of the operation. It just executes whatever you query the data. If you ask the data to give me whatever table, it will give you whatever table. If you ask the data to give you the customer table, it will give you the customer table. If you ask the SQL to give you that kind of table as it was earlier, sorry, if you ask SQL to give you the flat table, so to give you the flat table like this, something similar to that, it will give you. So based on all these links that exist among these different tables. So the RDBMS, as I said to you, is here. Uh, just give me a second with you. Yes, the RDBMS is here to uh, process whatever query that you have and give you the result that you want. It's what we call the engine. It's just basically what is retrieving the data, what is processing that data, and giving you whatever result you may want from that. Now, when we are talking about a RDBMS, before we get there, you need to have a user and an application somewhere. There should be a starting point, as I said. Now, when we talk about a user or an application, I'm talking about maybe a mobile app or a website that needs to interact with data. And when these data are interacted with, there are people who are querying data. For example, I want to add, let's suppose you want to add KFC in whatever KFC, let's suppose a Twister or maybe whatever from a KFC, you want to add it in your cart. You are making a request. So there is a user who is using an interface somewhere and making that request, and that request is being um, updated and processed somewhere. So you're making a request, and when the request is made, it generally goes through a language that we call structured query language. The request is translated into what we call a structured query language. That's what we refer to as SQL, that you have had some chance of having a look at. Now, SQL is a way of communicating with your database. That's basically what it is. For example, you have seen me doing that a few times, select star from. When you say select star from a particular table, just look at the highlighted, forget the where for a moment. If you say select star from reservations, it will give you all the columns that you have in the table reservations. However, uh, sometimes instead of saying star from, you say select whatever column from reservations. That's also a possibility. But when you say where hotel location is equal to, it means that now instead of talking about a column, when you say where, you are applying a filtering, then you are referring to a row, a particular row in your data. So when you say select star from reservations where hotel location is thick and flat, it means that you are not interested in all of the hotels like the North or whatever. You are interested in only thick and flat. So you can write down your query depending on what you are looking for. And then, as I mentioned to you, what an RDBMS is it's basically just applying whatever you are requesting. It's the engine that executes whatever you have made as query. That's basically what it is. Okay, the RDBMS. And for us, one of the RDBMS that we are one of the RD not one, but the RDBMS that you are using in this course is basically MySQL, as you have seen earlier. And then you have a concept of tables. So I've already mentioned to you what is a table. I've already given you an example of a table earlier. So normally these tables, if you are talking about a relational database, we normally have relationships among these different tables. Okay, and a table is generally referred to as an entity in a database management. We also refer to as an entity, and each entity has an attribute. We'll get into that again anyway in the when we are going to talk about an entity relationship diagram later. So these are the different things that you need to know. You go through the user, you have a query that is made, you have the engine that processes that query, and then it gives you a table. Of course, the results is a table that is going to you are going to see. Like in the context of select star from, select star, where is it? Sorry. When you say select star from reservations, it will give you all the columns of reservations in the form of a table. So that's a little bit how an RDBMS works. You have a user that requests something, that not a request something, a user that will need to something, and then it will pass on through a query language. The query language will be executed through a system that we call an RDBMS system, and for us it is MySQL. And then the result of your query will be in the form of a table. All right, in the form of a table. Now, when you're talking about RDBMS, there are other concepts that are important. It is the acid property. When we talk about acid property, we are referring to atomicity for A, consistency for C, isolation for I, and durability for D. I repeat, atomicity, consistency, isolation, and durability. All these are concepts that we want to abide by when we are working with a relational database. So what are all these? You already have these examples here that you can go through on your own, but let me just go back in my slides to be able to illustrate this concept of atomicity, the acid property rather. Okay, so let me go back here. So when we talk about atomicity, what do I mean by that? What do I mean by atomicity? Let me just give me a second with you. I connect my Wacom. Here we go. Now, the concept of atomicity is the concept of all or nothing. Let me just give you an example, which is relatively easy to understand. Make as if you transfer 1,000 rupees from account A to account B. Okay, you want to transfer 1,000 rupees from account A to account B. Okay, what does atomicity ensures? Atomicity, this concept of atomicity, when we're talking about acid, the first part, which is A, which is atomicity, it ensures that both of these steps happen. What steps? First of all, the 1,000 rupee is deducted from A, and secondly, 1,000 rupee is added to B. That's what it is. If there is a failure somewhere, for example, if there is a system crash, if there is a system crash, what happened? No money is lost or no money is created. So the concept of atomicity will say all or nothing. Either it concludes the transaction by completing it, taking removing 1,000 here and adding 1,000. But if in between there was a system crash just the moment that you have done the transaction, then atomicity ensures that none of it is done. That is, the entire record transaction should be either complete or none of it is completed at all. Nothing happens. You don't have the minus 1,000, you don't have the 1,000. That is the concept of atomicity. I think this is quite normal. That's quite important. If there was a system crash and somebody and your amount of money has been deducted and the person that you have transferred the money to did not receive the money, that would have been very complicated and create a lot of issue. There's also the concept of consistency. Now, what is consistency? Suppose, again, in the context of a bank, me and my wife want to make a transfer of, let's suppose, a certain amount of money, let's suppose 1,000 rupees, to a person, all right, from a single account, from a joint account that we have. And normally, both of us are using our mobile separately, but are making the transfer for certain reason. Let's suppose we've done the transfer at the same time. All right. If we are doing the transfer at the same time. So let's suppose I'm doing the transfer at 8 p.m. and my wife is doing the transfer at 8 p.m. of the same amount of 1,000 rupees. What happens here? The concept of isolation means that there is no interference. No interference. What do I mean by no interference? It means that even if me and my wife, we've both of us made the transfer at exactly the same time from the same account, isolation will ensure that these two actions don't mess with each other. Isolation will ensure that these two actions, that is, my transfer and that of my wife, do not mess up with each other. What happened is um, it's as if the transaction was done one after the other. Even if they happen at the same time, it's as if the transaction has been done one after the other. Whether me first or my wife first, it doesn't matter, but it is as if they happen one after the other. That is the concept of isolation. It doesn't make an interference. So transaction, by considering the concept of isolation, transaction do not conflict when run in parallel. That's what the concept of isolation is about. Transaction don't conflict when run in parallel. That's what about isolation. Then there is a concept of durability. What is the concept of durability now? Consistency, when you refer to it, it's about the fact that rules must be followed. Rules must be followed. What does it mean? For example, a bank can say you cannot have negative balance on your account. No account can have a negative balance. So if it says that no account can have a negative balance, let's suppose you have only 500 rupees on your account and you still want to do this transfer of 1,000 from your account A to another account B. So if you were to carry out this transaction, what would happen is that you have only 500 and you want to transfer 1,000. It means that you will move to a negative balance. But if you move to a negative balance, we should not forget that the rule of the bank is that you should not have a negative balance. So what would happen then? At no point in time will the transaction be completed because it fails to abide by the rules of the bank. So if it fails to abide by the rules of the bank, then consistency will ensure that the transaction fails. It ensures that the transaction will fail. So it won't complete the transaction. That's the concept of consistency. Now, apart from consistency, there is the isolation principle now. The concept of durability is quite simple. The moment that a transfer has been done, the moment that the money has been transferred, and let's suppose it has been successful, the transfer, the change, that is when I say it has been successful, the moment that I've been able to transfer the 1,000 rupees to somebody, the moment that the transfer has been done and it has been successful, that change is saved permanently. So, what is the concept of durability? It ensures that your record stays safe. Okay, so in other words, if I've been able to do the transfer and it has been successful, that change is saved permanently. Is saved permanently. It's saved permanently. What happened? What do I mean by save permanently? Even if the power goes off or there is a server crash or whatever it is, your transfer is not lost. The transfer has been done and it's over. It has been done. That's all. It's not lost. It's not because I've already done the transfer. After 1 second, there is a power crash. Before 1 second, it was successful. Now, after 1 second, it has been there has been a crash, and then you see that the transfer has been reverted back to what it was before. No, that's not possible. Through durability, it ensures that once committed, the change stays in the database forever. The moment that you have committed, the change stays in the database forever. That's a little bit what we talk about in the concept of ACID, that is atomicity, consistency, isolation, and durability are the principles that we want to abide by when we are working with a database, a relational database. So maybe I'll go back to this small example that I was referring to earlier. So you have here different examples that you can check, other additional examples that I've put here that you can check. In real context, there are different RDBMS that are used, all right? As I mentioned to you, what is an RDBMS earlier? It's a software that receives and processes the SQL query. So there are different software that exist. You have the MySQL, you have a Postgre SQL, you have the Oracle, which is a very well-known one. Generally, MCB and even University of Mauritius uses Oracle, uses Oracle, and many companies, reputed companies in Mauritius, make use of Oracle as well. So, but Postgre is also SQL is also good. MySQL is not bad at all, but Oracle is the best, obviously, in that in those few examples. In terms of RDBMS software, Oracle is generally considered to be the best. All right. I've given you here a quick overview of these three different RDBMS that exist, and we in our course we will mainly focus on MySQL, which is the most popular open source database. Okay, it's an open source database. Oracle is not necessarily open source, but MySQL is open source. It's still reliable. It's high performance, everything. You can use it without any problem. It's very good, in fact. But if you want to go a little bit further, a bit more advanced, you can move to this one. And if you want to go a little bit more advanced as well to ensure safety of data and so on, like banks, reputed institutions, then you might have to go for Oracle, which is a bit like an industrial grade software. Now, I gave you the advantages and disadvantages of each of these. You can go through them on your own. I'll leave it to you. And why does it matter? Without an RDBMS, managing large data sets would be chaotic. Without an RDBMS, managing large data set would be chaotic. You need an RDBMS to manage large data set. Data could become inconsistent, duplicated, or lost. It would, let's suppose if you were to keep your data in a flat Excel, as earlier I mentioned to you, when you're dealing with a big data set and you wanted to keep it this way, all right, you wanted to keep it this way, then it would not be very good. It is subject to errors, it is subject to inconsistency, duplicated values, or loss of information. All these kinds of issues may happen when you are modifying something. For example, if you modified, as I said, Mocha here for Maesh, and then you forget to modify it in the last row, that would be a bit problematic. So it would be difficult to enforce rules, ensure data integrity, and prevent errors, especially with multiple users accessing the data simultaneously. With RDBMS, you are able to do all these because in an enterprise, in an organization, very often there is not only one person working with the single data. There might be different people working on a database altogether. Okay, for example, if you have records, if you are in a human resource, let's suppose you are part of a human resource department of a company, there might be the human resource manager and the assistant of this human resource manager who are both working on the same database, modifying the record of an individual, of an employee, for example. So if you did not have an RDBMS, you would not be able to ensure this atomicity, consistency, isolation, and durability. That would be a total mess if we tried to work it on, for example, on a Google Doc, or on a shared Google Doc, for example, or on a shared Excel file. It's not going to ensure atomicity, consistency, isolation, and durability. So to ensure all this, it's always good to have an DBMS that helps to do whatever you are working with. So to sum up, maybe I've been talking a lot about different things and you might got lost here. The idea is that you want to move from a flat table to different single tables that are linked to each other. And the way to manage these is obviously through SQL queries and mainly through a software that we call an RDBMS. And that software for us is MySQL, that is used to run our queries. And these queries will yield different tables. So whatever table you want, it will yield this table. So the next step is to talk about entity relationship diagram. It's to talk about entity relationship diagram now. I'm going to talk about an ER diagram now. Normally, an entity relationship diagram, that's what we refer to as the ER diagram. It's a diagram that will normally show the relationship that exists between different entities, what we also refer to as tables. And it will enable us to know how different tables are related to each other in the database. That's basically what it does. When we refer to as an entity, before I get into explaining to you what it looks like, we need to understand the concept of an entity. In a database, when we refer to as entity, we are referring mainly to a table which contains different information. Now, the table you have, for example, if you have a university database, let's suppose if you have a university database, in the university database, you will have several different tables that may exist. There might be a table that relates to student information, student ID, you have name of the student, and so on. Then you might have another table called course, which will contain, that table will contain all the different courses that you have at university, respective of who the student are. You might have other information as well. So these are what we refer to as entities. The entities are the tables themselves. Now, under each table that you have, for example, if you have a student table, you will have different information. You will have, for example, the student ID. I just write as STID here. You will have a different information like student ID, first name, you will have surname, and you maybe have other information related to that student as well who has joined the university, maybe their high school grade or anything else, all right? So then these different columns that you will have for each of these um, entity, for this entity particularly here, student ID, these columns are referred to as attributes. These columns are referred to as attributes. All right, they are basically the properties or the traits of that particular entity. So you have a student ID, the name of the student, the first name, surname, you have the date of birth and email, and all these different information are what we call attributes. So just bear in mind, in a database, when we are referring to an entity, we are basically referring to a table that contains different attributes. And now the other thing that you would like also to know is that in when you are going to draw an ER diagram, there are certain notation that we generally use. For example, there is the crows notation that is extensively used when drawing an ER diagram. Now, when we refer to as a crow's notation, there is something that we refer to as a cardinality. Now, the cardinality expresses basically the relationship between the different tables in a little bit more details. For example, there is a cardinality of 1 that we will generally draw like this. There is a cardinality of many that will generally draw like as you are seeing here. There is a one and only one cardinality that is like this. We use that notation. The zero or one cardinality, which is this. The one or many cardinality, which is this. And the zero or many cardinality, which is this. Now, you may ask yourself, what is all this about? I believe that the best way to explain that would be through a simple example. And for that purpose, we will start by taking an example of a database, all right, where we will consider a household database to make it easier. We are going to consider a household database, all right. Let me just write this down here. We are going to consider a household database. And we are going to define our different entities. We are going to define our different attributes. And we are going to draw an ER diagram to describe that the relationship that we have between these different entities. Let's start by the concept of an entity. In a household, normally there are different examples that we can take, but let's take, for example, the first situation where in a household, you will normally in a household database, first of all, you will have a house, all right? You will have a house. And then apart from the house, you may have different rooms in this house. You may have different persons in this house. You may have different appliances in this house. All right. And you will have, for example, for each appliance, you might have a warranty card as well. All right. There are many other things that you may think of that you may exist in a house. So the first thing is that when you represent an entity in the context of in the context of an ER diagram, you will start by drawing the um, entity using a box. Generally, we put that as a title here. That's the first thing that we'll do. We'll start by defining your entity using a box as the first step, as you are seeing here. So we have here in our example that we are taking 5 different entities. All right. And for each of these entities that we have the attributes that we have for each of these entities. For example, in the context of the house table or the entity, you have the house ID. That's already one thing that you might have. You also have the house name. What is the name of your house? Maybe um, in a database you have the house ID. If you have a case where there are different houses, you may refer to them by their name. For example, one would be Duplan family house or whatever it is. You can give it a name, and then you have the house ID. So you have a table where you might have different houses. You have in the houses, you have information pertaining to their rooms, pertaining to the persons, to the appliance, and the warranty card that you have, and so on. I suppose you are doing a household budget survey and collect all these different information. So at least you will have different houses and different IDs for each of these houses. All right. And then you will have the address, for example, of the house. All these are different attributes that relate to the house. For the rooms, you will generally have a room ID. You will have generally the room name itself. Let's call it room here. The room name, it can be a bedroom, it can be the living room, it can be bedroom one, bedroom two, living room, kitchen, or whatever it is. And then normally you will see that each room on their own does not mean much unless they are related to the house. You understand? Every room should be related to the house. So, in other words, one way or the other, under the room table, you will normally have also the house ID. You will also have the house ID there. These are, for example, the different attributes that you might have for the rooms. You have the room, the house ID itself, and so on. For the persons now, you will have a person ID in the data that I will explain to you what are all these about in a moment. For example, here for the house ID, we will generally refer to it as a primary key. And for the room ID, we will refer to it as a primary key in that particular data table. And for the person ID, we will refer to it as a primary key as well. Now, when we refer to as a primary key, it means that it is a key or an identifier, if you want, that uniquely identifies the different rows in that particular table, that uniquely identify the different rows in that particular table. For I will get into that a little bit later, but let me just mention it quickly. For example, if you talk about a data set where you have rooms, all right, let's talk about a data set where you have rooms. Maybe I will just open an Excel file just to illustrate it so that it doesn't become messy here. Let me just open an Excel file just to illustrate what I'm referring to as primary key. Maybe I'll explain it right now itself and the concept of foreign key. So let's suppose here you have a situation where you have different rooms. All right, you have a room data. Let's call it a room table. And in that room table, as I just showed you here, you have a room ID. You have a room ID. You have a room name. You have also the house ID as you are seeing here. So these are the different information that you have. Now for the room ID, you might have bedroom 1, you might have bedroom 2, for example. You might have bedroom 1, you might have bedroom 2, you might have kitchen, and so on. All right, kitchen, or you might have whatever it is, different rooms. Now you have these different IDs. For example, you have these three different rooms exist under household under house ID 1. These different rooms exist under house ID 1. So we will put it's only for the first house. There are 3 rooms, let's suppose, make it easy. These 2 bedrooms and the kitchen. Now there is another person's house, which is going to be house 2, let's suppose. And that house 2 is got a kitchen, is got a living room, let's suppose. Now, let's try to understand that for a moment. You see, each row in that table that we call room table, maybe just to avoid confusion, let me just put that as room name. Okay. Now, in that room table, as you are seeing right now, there are, let's suppose this is not here for the time being. Okay, this is not here for the time being. You have the room name and the room ID and the house ID. So the room name bedroom 1, bedroom 2 for house ID 1, for house ID 2, and the kitchen for house ID 1. And then you have kitchen for house ID 2. You will see that I cannot use either house ID to uniquely identify each row in that particular table. Why? Because house ID cannot be said to uniquely identify because you have three different IDs already that can represent different things. These three IDs represent, for example, bedroom 1, bedroom 2, and kitchen. These two IDs represent kitchen and living room. So I cannot use this as a unique identifier to describe my table. On the other hand, you have room name. I cannot use room name to uniquely identify that table that we have here. Why? Because if you look at bedroom 1, it's true that it is not repeated in this example. Bedroom 2 is not repeated, but again, you have kitchen. Kitchen is being repeated twice in that data. So I cannot use room name to uniquely identify these different rows that I have here because they are duplicated here, as you can see. So maybe in for another household ID, you will have another kitchen. So I cannot say that kitchen is going to uniquely identify a particular row. That's why you will see, for example, I've defined what we call a room ID. When you call a room ID, you have room ID 1, room ID 2, 3, 4, and 5. You will see that now, when I create that room ID 1, 2, 3, 4, 5, it means that 1 is not repeated again under that column, 2 is not repeated again under that column, 3 is not repeated again, and 4, etc. is not repeated again, which means that 1 uniquely identifies that first row in my table of I, room table, where the first row is referring to bedroom 1 and house ID 1, where the second row is referring to bedroom 2 and house ID 2, and the third row represents kitchen and house ID 1, and the fourth row is referring to kitchen but house ID 2. So that's what we refer to as a unique identifier for that particular table. It will always be unique. You cannot have duplicate values for that one. And this is generally what we refer to as the primary key in the context of a database. Primary key. Primary key, in other words, is an identifier that uniquely identifies every row in your particular table. So that's very important that you understand. I will also discuss the concept of foreign key shortly, but let me get back to my example I was referring to. So you understand what I mean by primary key now, what these are about. So, with regards to the person table, with regards to the person table, you have the person ID himself that represent the primary key. You have the full name of the person that you may wish to include, or you can also include it as first name, surname, and so on if you wish. It depends. I'm just taking an example here. You also have the person that belongs to a room generally. So you will have a reference to a room ID. All right. Now listen to that. If you look at the house here, you will see that house ID repeats here. And if you look at the room here, you will see that room ID here, it repeats from this room here. So there is a sort of relationship that you will see between house and room that is that the relationship is linked through these keys here that we refer to as household ID. And you will see that household ID is repeated here. That same household ID is the same household ID that will exist in the house. It's just like the primary key, but located elsewhere here. And this now is not referred to as a primary key, but we generally refer to it as a foreign key. So, what is a foreign key? It's similar to what we refer to as a primary key, but somewhere located somewhere else. Now, the primary key is located in the current table household ID, but house ID, sorry, but the house ID if it is repeated in a different table, it's no more referred to as a primary key because it is not a unique identifier of that particular table, but but it is linking these two tables together. So if they are linking these two tables, we refer to that as foreign key. So the foreign key is just similar concept to the primary key, but the only thing is that it is located elsewhere in another table. The same vein, you will see that in our particular example here, the room ID links, as you see here, the person table in the room, and this is referred to as a foreign key. So you already have an idea about these different attributes. And I'm also not only mentioning the different attributes, but I'm also talking about different keys. So you have something that we call a foreign key, you have something that we call a primary key. And then another entity that we add in our household database is the appliance. So for example, you have the appliance ID. That's one thing. Of course, the appliance ID logically for each appliance, with regards to whatever information, you will have a unique identifier which we refer to as appliance ID, and it's a primary key. You have the name of the appliance, obviously, that we will have. We have the brand of the appliance, whatever brand we have, Samsung or whatever it is. And then you have a room ID where this appliance is located. Now, for example, if there is an appliance that is meant to be in the kitchen, so it will refer to the room ID that refers to the kitchen, all right? So that's the kind of information. And then again, you will see that room ID becomes a foreign key in this particular example. And then you have the warranty card. For example, we have the warranty ID. Again, the warranty ID acts as a primary key again because it is meant to identify uniquely every row that you have in the warranty card here. And then you have, for example, the appliance to which this warranty applies. You have the appliance ID and the appliance ID. You will see that it links these together. So obviously it becomes the foreign key. So these are the kind of information that you have. These are our tables that we have, and these foreign keys, they are going to connect them together. The foreign keys are what brings that relational aspect in that database. Without these foreign keys, these becomes just flat tables without any connection. These foreign keys are what connects these different tables in our database. And so you will see that room links to houses, you will see that people links to room, you will see that appliance links to rooms as well, because you will see that appliance, you have a room ID which links to room as well, and it also links to the warranty card, and so warranty card links to appliance and so on. So this is what we refer to as an entity, as I mentioned to you. These are the attributes, and you have a foreign keys that brings in this relational aspect. Now that you have understood what an attribute and what an entity is, we can get into this concept of cardinality that will complete the ER diagram. So that will connect these ER diagram through these different notation that we call the cross notation, as I mentioned to you. And how do we get into that? Let's start by the first example, where we will refer to as the house and the room. So you have the house, which is our first entity. Excuse me, I'll just write this again. You have the house, our first entity, and you have room. Now, for the house, you have different information. You have the house ID, which is our primary key, as I mentioned to you. You have the house name, which is specific to this house. You have the address of the house and any other information relevant to the house. Then you have a room. Now, when we refer to the room, you have obviously the room ID, which is again the primary key. You have the room name, whether bedroom or whatever it is. You have the house ID again. Now, when I say the house ID, it's the same house ID that you have here, which is the primary key, but in this particular table, it's going to be referred to as a foreign key. All right. So, in fact, these two tables, they are related to each other only by their foreign keys. These two tables, they are related by their foreign keys. Now, the question that I need to ask myself now is here, what is the minimum number of room and the maximum number of rooms that a house can have? I repeat, when you have reached that end point here, to be able to know what cardinality to include, you need to ask yourself the minimum number of rooms and the maximum number of rooms that a house can have. Normally, a house, normally we would expect that it has got a minimum number of one room and a maximum which can be infinite, or to make things easy, we will say many. We'll have many rooms. All right. So when we say the cardinality for room with respect to house is minimum one and many, we will normally use that notation from Crow. All right, that Crow's notation, excuse me. That Crow's notation here refers to one to many possibilities. So then what you do is you just draw it like this. Here we go. We have this Crow notation that refer to the fact that there can be one room or many rooms in a house. Now, having said that on this side, let's move on the other side. How many house can a room have? I think this is a very easy one. How many house can a room house? A particular room would have only one house, obviously. If you're talking about the kitchen of household, let's suppose of my household, there is obviously only one house that this room will exist. So, in other words, there is only one minimum and maximum one house that contains a particular room. So this is why you're going to use this notation one and only one house as a room, particular room. So in other words, that's where you get into that notation that I mentioned to you here, that you see here, one and only. So you've seen already these two notations. If you say that you allowed a room to have no, you allowed a house to have no room at all, instead of using this notation that I just mentioned here, this notation, you could change that to a circle, to a zero if you wish. All right, this would refer to that there is a possibility of having a minimum of zero house. So that's how we start to define the cardinality. Let me continue with another example now in the same database. Now let us take the example of the person entity. All right. So let me erase this first. Let's take the person table now, or the person entity. Now in the person entity, again, you will have different attributes for that particular person, obviously. You have the person ID, obviously. And again, the person ID would refer to as primary key, obviously. All right. You also have a full name of a person. the full name, or it depends if you want to have the first name and the surname, whatever you wish, it's okay. And then you have the room ID of that person, the room ID. And again, the room ID here is a primary key on the room table, but on the person table, the room ID becomes the foreign key. So again, you will see that these two are linked together by their room ID. Now, the fact that they are linked together, there is a relationship between room and person. We need to ask ourselves what is the cardinality to include for person and what is the cardinality to include for room. For the person case, what do we need to ask ourselves? What is the minimum number of person that you have per room? What is the minimum number of person that you have for a room? And what is the maximum number of person that you can have in a room? For example, in a room, you would say that normally the minimum number of people that you might have in the room is zero because a room may be unoccupied. All right. But you could also have one person in a room, you could have two persons in a room, or three, or whatever it is. So theoretically, you have many. So if this is the case, it means that you will have this notation that is going to be used to represent that cardinality here. So when you're drawing the ER diagram, you will normally use that notation to represent this cardinality. Now let's take a look at, so excuse me, let me just go back here and let's do it again. So now it's a bit what I just explained to you here. All right, sorry for uh, this bad in writing, but it's okay. I guess you understand what I'm referring to here. So you have here this zero or many option that is considered. Now let's go back to the case of a room now. How many rooms, here in this particular example, how many room can, uh, what is the minimum number of room and the maximum number of room a person can have? To answer this, it depends. For example, some of you may say that a room, that a person may have no room at all. So then, if a person has no room at all, it would mean that this is zero room. Now, this is where you have to be careful. If you decide to say no, I want every person to have a room in this house. So a person cannot have no room at all. Then it will need, the minimum needs to be one. That makes more sense, in fact, because generally when you have a household data here, the person needs to have at least one room to stay in. So the minimum number of room that a person can have obviously is one in that particular example. But on the other hand, what is the maximum number of room that a person can have? Now, this is a bit where you have to be careful. All right. Some of you may say the maximum number of room that a person can have can be two, can be three, can be four, and so on. Now, if we are going to model such type of situation, we will need to use a bridge, a bridge attribute here. Not attribute, sorry, a bridge entity again here. But I'm not going to get into that detail. Yeah, all right, because if you normally in this particular example, when you look at it, you cannot have more than one room assigned to a person. What do I mean by that? If you look at the example of a person table, let's try to imagine the person table for a moment. You have the person ID, you have the full name of the person, and you have the room ID. These are the information that you have for the person table. So person ID 1, 2, 3, 4 are unique, and then you have the full name of that person, whatever name, let's suppose RT, JR, or whatever it is, okay? And we move on. And then According to the setting of this table, you have a single column for room ID. If you have a single column for room ID, this enforces room 1, for example, for RT, and JR cannot have room, uh, sorry, JR, RT cannot have another room. For JR, you might have a room 1 as well, if you wish, that's fine. For another person may have room 1, but for RT, there's only one room ID that is available. It's not like as if you have a second room option here, room 2 option, let's suppose, where you allow the possibility of a person including another room, let's suppose 2 here, ID 2. So there's the way that it is set here implies that you have only one room that can be assigned to a person, the way it is designed in this case. So in other words, the notation that I will use is again this double bar here, which represent one and only one room for a person. Now, as I said to you, if you allow a person to have no room at all, if you allow a person to have no room, let's suppose a person to have no room, then when you are creating your database, you may allow the option of null to be included. But if you decide that a person should automatically have a room, like um, a person should automatically have a room, is then forced to have a room, then you might have to use a not null constraint. Now let's take a look at the uh, relationship that we have between the room and the appliance. To start with, let me just erase this different information here. All right. So when we're talking about the room and the appliance, let's talk about the appliance first of all, entity. Now, under the appliance entity, we have quite a number of things. We have the appliance ID. We have the name of the appliance, obviously. We have the brand of the appliance, and obviously we have the room ID. For example, if an appliance is located in the kitchen, or if an appliance is meant to be in the bedroom or things like that, this is what we have. So we have all these. Obviously, the appliance ID, as I mentioned to you, is a primary key, and here the room ID is a foreign key. So what do we want to do now? We want to evaluate the relationship that we have between the appliance and the room ID. Okay. So when we're talking about the appliance and the room ID, we will need to consider, for example, here the let's try to find out a way of doing that. First of all, let's get the relationship like here. Okay. Let's take it from there if you wish, and let's put it on this side. All right, something like that. So what's going to happen normally, generally it's going to be if you were to draw it formally, it would have been drawn directly from the room ID, but let's just get this like this so that it doesn't get messy here, because my aim is to explain to you what cardinality is, huh? So the thing here is we need to ask ourselves again, what is the minimum number of appliances and the maximum number of appliances that a room can have? So obviously the minimum number of appliances that a room can have is 0, and the maximum is, of course, many. So the best way to denote that would be through that notation as you are seeing here, right? Through that particular notation. 0 as you are, oops, excuse me. So this is the notation that we will generally use to represent that. Excuse me. So now, with regards to the room and the appliance, how many room can an appliance have? Obviously, an appliance cannot be in multiple room at the same time. It's going to be a single one and only cardinality here for the number of rooms that an appliance can have, can be located, in other words. So there's only one and only one room. Now let's take a look at the relationship between the warranty card and the appliance. Obviously, warranty card entity and the appliance. So under the warranty card entity, you will have the warranty card ID. There will be there obviously the appliance ID. There will be also the provider of that warranty card, obviously, Coats or whatever company. And you can also get information in terms of when the warranty card expires on, and then this would be obviously um, a date. Now, this is done. So what we have here, we have obviously our primary key, which is the warranty card, and we have the foreign key. By the way, the appliance ID and the foreign and the warranty ID are going to be both unique in this particular context normally. I'll explain to you why in a moment. So this is what we have. So they are connected by their appliance ID. How am I going to decide what cardinality do we have? Obviously, the same question that we ask, what is the minimum number of warranty card that an appliance can have, and what is the maximum number of warranty card that an appliance can have? Obviously, I guess you would have understood that the minimum number of warranty card that an appliance can have is zero, and the maximum number of warranty card that an appliance can have is one. Why? Because you have this possibility that an appliance has no warranty on it, for example. So, what is the kind of notation that you will use? This is where you get into this notation 0 or 1 notation. So, let's get back to this. You have this notation of 0, excuse me. Let me just, maybe I will just make it a little bit easier. So, the cardinality is, excuse me, the cardinality is 0, 1. All right, excuse me. I just draw this a little bit better here. So the cardinality is going to be 0, 1 here. So because you have a possibility of having no warranty for an appliance, and you have maximum of one warranty card for an appliance, that's normally how it is. On the other hand, the only issue I have here, maybe I will need to draw this again completely. Just give me a second with you. I will, just to make it easy, I will just make the connection like this, okay? So we have a 0, 1 here, notation. And on this particular case here, for the appliance, how many appliance can a warranty card have? Was a question. How many appliance can a warranty card have? Obviously, there will be only one appliance and only one appliance for which you will have a warranty card. So you cannot have zero appliance for a warranty card. If a warranty card exists, it is obviously because of an appliance. So you will have only one and one appliance for a warranty card. So that's a little bit how you can draw the entity diagram. What's the purpose of all this? The purpose of all this, obviously, is to be able to create our database. Now, we can create our database. We know that there are relationships among them. We know that they are related by whatever means here. And based on these relationships, we can start to enforce constraint. We can start to include the different keys, the primary keys, the foreign keys, and so on, and so on, and so on. So my next step is to show you how we can create these primary keys, how we can include the not null constraint. For example, you would recall earlier I was mentioning that there is the for a person and a room, there needs to be the not null constraint if you want to enforce a person to have a room. You would recall that earlier I mentioned that. So I will explain to you now how we translate all of these into codes, and we can then create our database accordingly. So let's move on and just remember what I've shown you here. Just take a screenshot of that, save it somewhere, and then I will show you how we can translate all that um, in codes. From the entity diagram, now let's get into MySQL Workbench. And we are going to include this different information and create a database with all these different entities and their attributes, including their not their cardinalities rather. The cardinalities is not going to be explicitly mentioned necessarily in the codes. We have to be careful about that. But when we are going to create our database with these different entities and attributes, we can do something that we call a reverse engineering, and we will get the the entity relationship diagram uh, drawn for you automatically by the MySQL Workbench. Just bearing in mind, though, that MySQL Workbench does not necessarily give you exactly what you have here. This is what I've just shown you is conceptual, but when you're going to do it practically using the MySQL Workbench, you might not get exactly the same thing. For example, the zero too many may not be shown in MySQL. It will generally show it to one to many. And even this last part here of zero or one and one and only one may not be explicitly shown in MySQL Workbench. But at least you'll get an overall idea of what's going on. So without much further ado, let's get into these codes and start writing down all these information. At the same time, I'll explain to you a few constraints, the not null constraint, for example, and I will explain to you how to include a primary key and a foreign key in your tables. So first of all, let's create a database. All right, let us create a database. The database will be called this will be called not district, but excuse me, the database will be called house manager database. Okay, so we create a database and we'll give it a name of house manager. All right, that's what we are going to call the database. Now, each time, as you would recall last time, I told you whenever you have to use a database, you need to always use this term use and then put the name of a database again. You don't need to call the keyword again, it's going to work perfectly well. So if you run that and you refresh here, you will see that the house manager database has been created. Of course, there is no entity, there is nothing in that database, there are no tables, there are none of these. So we start by creating the first table that we worked with is the table house. Let's create the first table house. When you're creating the first table house, you will need to include information there. What are the different information? Each time when you're creating a table, the first information that you are going to put, as you would recall earlier, is the house ID. And then I will put the name and then I will put the address. And I will consider the house ID as a primary key. So let's get there. Now that you can see the full tables, how they are created. Let's get into the first one, the room table that I wanted to discuss. You will see that there are similar things compared to the others. You have the primary key, the voucher, and so on, the not null constraint. There is also another constraint that I have set here, and this not null constraint is a foreign key constraint. All right. Now, how do you include a foreign key? You would recall earlier that I've been explaining to you that house ID is a foreign key for room, but it is a primary key for house. Okay. A foreign key is basically just like a primary key somewhere else. Okay. So what we have here is we need to define that foreign key. How do we define that foreign key? We will start by using the keyword words foreign key, and then we say what is a foreign key. The foreign key obviously is house ID, the same name that you have here, the same name house ID, and then you will say this house ID is a foreign key, as you would see here, house ID. That is, I have room ID, I have room, and then I have house ID. But that house ID is not the same. Is not the same. Sorry, this house ID is referencing the house ID from this house table. If I just put the foreign key house ID and I do not put the referencing where it is, that would not make any sense because I'm not connecting it to the source. So this house ID is the same thing that you're going to write here, but related to the primary key house ID from the house table or the house entity. So this is how you define a foreign key. There are other ways of also defining foreign key because the way that I've defined a foreign key here, I did not explicitly name the foreign key. Of course, I've given the name of house ID, but I did not. The foreign key normally, it's a constraint where you can name it. All right. So you can name it. For example, you could add an additional line here. You would say constraint, something like that. Constraint, and then you will give it a name. Let's suppose F key, room, house, because foreign key will every foreign key is unique to itself. All right, for that room table you can call it for room, or you can later, for example, let's take this one. You have this room ID for appliance. This is a different foreign key, so then you can call it appliance room, things like that, you see. So the foreign key can be named if you want, but for this particular example, I'm not naming it. I'm just mentioning that you can do it, but let's leave it for the time being and make things simple. So you can just define a foreign key as I'm just showing you here. It's not necessarily named. The same thing applies for table person. Same thing applies for appliance, and the same thing applies for warranty card. Now, when this is done, just give me a second. I will just drop all this, and then I will run everything, and then we'll refresh, and then you will see that you have all these different tables have been created. Obviously, these different tables contain no information yet. We will need to populate that. You will see if you look at that, there is nothing in that table. It's just that we have defined their different fields. If you click on appliance, you will see appliance ID is a primary key, the appliance name is a voucher, the room ID is an integer. You have, for example, the different foreign keys that have been defined for appliance, and it has been defined as appliance IP FK underscore one. And you will have the same thing for house. You can go on and just check what you have, and so on and so on. This is how you can create a table. Just for your information, there is no data here. There is nothing. I'm just creating a relational database using these foreign key principles where these different tables are linked together. Instead of having a single flat table which contains all these different information, we are basically creating several small tables that are linked to each other through the foreign key. So what did we do? We started by drawing the entity diagram, and from the entity diagram, we are able to create our database as we wanted, our schema, bearing in mind that you would recall, for example, let me just find this out here, for the person ID and room. If you look at the person ID and room, so you see the not null constraint implies that a person should automatically have a room. If you did not include that here, then this would have allowed the possibility of zero. But in that particular example, it enforces a person to have a room. You see, it enforces a person to have a room. So there should be a minimum of one person in a room instead of having so, for example, here, what did this cardinality mean? It means that there could be zero to many person in a room, all right? Zero to many person in a room. But if you insert this not null, it means that you could have at least one person to many person in a room. So in other words, you should always have this information. And then you have also here the room ID, one and only one, which means that um, one room can contain only one person. One room can contain only one person for the different reasons I mentioned earlier. I'm not going to get there again. So that's how you create an entity diagram. You understand the different principles of the cross notation, how you can draw it. You can basically draw it very easily. But there is also a software that you can use to make things a little bit neater instead of drawing it like what I did here. You can draw this in a software. Let me just guide you to that software. To be able to uh, use that app before software, you can click on Lucid Chart. You type Lucid Chart in your Google search bar, and then you click here, lucidchart.com. When you go there, normally you would be required to log in. All right, you can click on login, or you'll sign up for free for the first time. Sign up for free, or even if you click login, you will see that when you have signed up for free, you can click login, and then when you click login, you can log in whatever means you've used. For example, me, I'm using Google Mean, so I will use Google. And then you will see that it will open a new screen like that. Okay, then you can start creating your entity diagram, relationship diagram, sorry. I will show you, for example, in my case, you will see that I have drawn it. Just wait a minute. Review. Let's just let it open. You will see that I've been able to draw diagram as it is here. There are so many things that you can do in Lucid Chart, but I'm not going to explain to you a software here. You can go and try to play around with it yourself and just draw these charts, draw these entity diagram on your own. You will see that there are the cross notation that you can use here. There are different cross notation. This is absolutely free, by the way. You can play around with that if you wish. If ever you want to draw a an entity diagram to define your schema, you can do that without any problem and play around with that. That's the same thing that I've done. Obviously, all these you will have to do it on your own. For example, if you believe that we should not have zero here as a possibility, you can automatically change that zero to something else. For example, one, where's it? One and many. All right, one to many. It all depends on what you want, depending on what you have included, whether you have included not null, things like that. If you have included not null, maybe there would be nothing there would be no zero, things like that. So you can play around with that. If for the first time when you are going to open it, you will get to this, and then you click on new, and then you click lucid chart blank document. When you say lucid chart blank document, create a document anyway, and then you will wait a few seconds. Let me just close that one. As soon as it open, I will just guide you through it, and then I'll leave it to you to discover it on your own. So when you are here, so you will normally not have entity diagram shapes yet or whatever. So what you need to do is to click more shapes. Sorry, not more shape, rather, excuse me, just a second with you. You click on this search button here, and then you type entity. That should work. Otherwise, I'll just show you something else. Wait. No, let's say on more shapes rather. Excuse me. Wait a minute with you. Let's click on more shapes rather, and find entity relationship. You see, you tick on entity relationship, and you do use selected shapes, and then now you have access to entity relationship. You can drag this here, you can drag whatever you want. If you want the type to be included, if you want the type and the key as well to be included, you can do that. You can play around with that and then include the connections and so on and so on. I'll leave it to you to discover it on your own. If in case you want to draw that ER diagram, for example, for your assignment with regards to your schema that you're going to create, you're most welcome to do it. Even if it is not a requirement, you're most welcome to do it. So that's all with regards to the entity diagram that I just explained to you.